Aviation has become very reliable with multiple levels of safety. Because things so rarely go wrong, it is increasingly harder to train for the things that could go wrong. Despite the safety benefits of aircraft automation, pilots sometimes have difficulty in quickly transitioning from monitoring to active and authoritative decision-making, especially in the event of unexpected and challenging situations. From a training and operations perspective, the Man4Gen project, funded by the European Union's 7th Framework for Aviation, has focused on 3 aspects of this problem. Development of more robust operational procedures to deal with unforeseen situations, providing better training for pilots to enhance the development of non-technical skills, and development of cockpit displays that enhance pilot situation awareness by presenting risk levels.
There simply cannot be a checklist for everything.
Joris Field is a human factors training and simulation expert at the Netherlands Aerospace Centre and chief scientist of the Man4Gen project.
When an unexpected event takes place, the crews must remember to prioritise their actions, always remembering to fly the aircraft first. In the experiments, we made an attempt to measure situation awareness and sense-making using different methods that were developed by our university partners from Linköping and Vienna.
The experiments were performed in the Grace Research Simulator at the Netherlands Aerospace Centre and at the Aves Research Simulator at the DLR. As the aircraft is climbing through a thick cloud layer, a lightning strike occurs, disabling the throttle on the second engine. The engine is locked in the high power setting. Their departure airport, where most services are available, is now experiencing crosswinds, making a single engine landing and possible go-around very challenging. 2 alternates are available, but each with its own hazards. Clearly, the crew must prioritize their actions. They need to manage the multitude of information. They must be able to anticipate and plan. They need to make decisions and execute the subsequent actions. However, as we learn, they also need to identify and prioritize the threats. While these crews have been trained on these 4 aspects, our observations indicated a need to emphasize the identification and prioritization of threats. We noticed that the crews were suddenly challenged with a high workload, forced to take leadership and communicate efficiently.
How a slight addition to the task can impact the workload is fascinating.
To better deal with situations like this, a decision support tool or complex situation management guide has been developed, which encompasses 3 concepts: managing time criticality, managing uncertainty, and planning for contingencies and changes. Man4Gen developed a memory items procedure that enhances operations during ambiguous conditions. Stabilizing the flight path should always be the leading action. Immediate threats are identified, prioritized, and their memory items executed. A short-term plan is created, followed by other actions that stimulate communication, decision-making, and application of procedures. So how do we train for these challenges?
Recurrent training and checking has often been based on minimum regulatory requirements, the checkbox approach. However, what if reality differs from these repeatedly trained events? For these reasons, flight training is leaning towards an evidence-based approach, where data is collected from the operation and used to adjust the training.
The scientific experiments of Man4Gen confirm the importance of introducing training events that deviate from existing training and checking regulatory requirements, emphasize the importance of applying non-technical skills, including situational awareness, leadership, workload management, application of procedures, and communication. Training scenarios should also require a realistic combination of the technical basic flying skills. After all, despite the complexity of modern systems, basic flying skills should never be forgotten. Part of the Man4Gen project has been to investigate possible enhancements to current flight decks. Questions were asked like, what if pilots were presented with a risk level indicator that displays the severity of a particular threat? For example, If an engine were to encounter problems, what is the severity of that risk in combination with the proposed flight path to an alternate airport? In the DLR AVES Flight Research Simulator, these and other risks have been investigated in a modern cockpit environment. Pilots are presented with a new risk indicator display, providing exactly that information.
With these developments, Man4Gen has demonstrated that safety levels in modern aviation can be maintained and improved when we properly train pilots to deal with a multitude of possible scenarios, provide them with the tools to deal with all situations, and hopefully enhance cockpits with improved information displays.
For more information, please visit our website at man4gen.eu.